Hello, and welcome to another lesson from Level Up Mathematics. Today we will be looking at interpreting the unit rate as slope. Before we do, let's look at a definition of unit rate. A rate is a comparison of two quantities that have different unit, such as miles and hours. A unit rate is a rate in which the second quantity in the comparison is 1 unit. So let's look at an example. The amount of money that Marcy earns is proportional to the number of lawns she mows, and she earns $70 for mowing 5 lawns. In problem A, it says, what is the ratio of the amount of money Marcy earns to the number of lawns she mows? Express the answer as a unit rate. So what we want to do is we want to make a ratio, and we're going to compare the amount of money she earns, dollars, to the number of lawns she mows, and I'll just use L to represent the number of lawns. So what we know from our given information is that the amount of money she earned was $70, and that was for 5 lawns. Now, if we divide that 70 divided by 5, we will get 14. So what we know is Marcy earns $14 per 1 lawn. $14 for 1 lawn. Now, to represent this proportional relationship as a graph, we know that we're going to have a point, because it's proportional, we'll have a point at, let me erase that. We're going to have a point at 0, 0. So we'll plot that on our graph. We know that we'll have a plot at 1, 14, because for 1 lawn, she earns $14. We know she would have a point at 2, 28, because she earns $28 for 2 lawns. 3 lawns would be $42. 4 lawns would be $56. And we know she earned $70 for 5 lawns. So that's what the proportional relationship would look like as a graph. Problem C, fill in the missing point, 1 comma blank, and label it on the graph. What does this ordered pair represent? So 1 comma, we already answered this question basically, 1 comma 14. And what it represents, we're supposed to label it on the graph, so this would be 1 comma 14. What does this ordered pair represent? It represents the amount earned for 1 lawn. And that's what our unit rate is. The amount of money per lawn, or for 1 lawn. Example 2. The height of a corn plant is proportional to the time it's been growing. If a particular corn plant has grown 15 inches tall in 6 days, answer the following questions. A, what is the ratio of the height to the number of days in simplest form? So this time they want your ratio to compare height to number of days. So we know that the corn had a height of 15 inches in 6 days. Now, they asked us to express this in simplest form, so I'll divide both those by 3, and that would give me 5 over 2. And to express it as a unit rate, I want to divide that. 5 divided by 2 would give me 2.5. And to express this as a unit rate, I would say 2.5 inches per day. Okay. Now that we know our unit rate, it's going to be very easy to create a table for this situation and a graph for this situation. So in problem B, they want us to fill in the table. So we have 0 days, we had a height of 0 inches. After 2 days, if it was growing 2.5 inches per day, if I double 2.5, the corn would be 5 inches. So I'm going to plot those 2 points. I have a point at 0, 0, and for 2 days, we have a height of 5 inches. After 4 days, let's see. So if I double the number of days, I get 4 days. So if I double the height, I get 10 inches. So for 4 days, I would have 10 inches. Let's see, they gave us 615, so I'll plot that. Now for 8 days, I could double the 4 days to get 8 days. So I double that. That means I would double the 10 inches to get 20 inches. So for 8 days, I would have a height of 20 inches. Now for 10, I could do 2 days times 5, because 2 times 5 is 10. So I would do 5 inches times 5 to get 25 inches. So for 10 days, 25 inches. So this is the graph that's representing the height of the corn over 10 days. All right. Problem D. Fill in the point, 1 comma something. Now, in our table, we did not include 1 day. We had 0 days, 2 days, 4 days, 6 days. But we can figure out 1 day because we know our unit rate. And our unit rate tells you how much per one thing. So we know that our missing point must be 1 comma 2.5. And if I were to label that, that would be right here, 1 comma 2.5. So that ordered pair was actually on that line. It's just that we didn't specifically plot it as a graph, as a point, excuse me. Now, what does this missing value represent? It represents the height of the corn per day, per 1 day. All right, unit rate and slope. In a proportional relationship, the ratio of y to x, or y over x, is constant, and this ratio is also known as the slope of a line. Now, you've probably seen the word slope in previous courses, but we're going to explore it a little bit more today as it relates to proportional relationships. So in example 3, it says each graph below represents a proportional relationship, and that's very important that we know that. Determine the slope for each of the following. So to determine the slope of a proportional relationship, we simply need to find the ratio of y to x. And that's exactly what we were doing back here, where we found the ratio of the height to the number of days, or the ratio of the money to the number of lawns. That's all we were doing, was finding the ratio of y to x. So we've actually already been finding the slope of each line. Now, when you're given a graph, you want to first kind of look at the graph and read it and interpret it, what's going on here. So in our first graph, problem A, on the x-axis, we have the number of candy bars. On the y-axis, we have the total cost. The total cost. So in this problem, it's going to be the amount of money over the number of candy bars. So I'll just put a C. The amount of money over the candy bars. Okay. Now, the next thing we're going to do is we need to find a friendly point. In our previous graphs, all the points were pretty friendly. We want a friendly point on this graph. So let me enlarge it a little bit so you can see the friendly point. So I'm starting at 0, 0, and as I follow along, boom, right away I see a friendly point there, a friendly point there, a friendly point there, and a friendly point there. So I only need one friendly point. So I'm just going to pick the very first one and use it to get the ratio of y to x. So for this point right here, the y value was 1 and the x value was 2. Now, if I was asking you for the slope, you could box that in. 1/2, I would accept that answer. However, I want you to notice that the graph is talking about money per candy bar. In other words, what is the cost for one candy bar? And sometimes we say this, but it's not that common to say $1/2 per candy bar or $1/2 per for each candy bar. So I'm going to write that as a decimal. The decimal conversion or equivalent of 1/2 is 50 cents. So I know that the each candy bar is 50 cents per candy bar. So either answer is correct. I just think if you're working with money, it's better to use decimals in general. Okay. All right, problem B. Now, in this problem, we have, again, the first thing you always want to do is read the graph. We have number of books on the x-axis. We have the total width in inches on the y-axis. So what we're going to compare to get the slope is the y. Whoops. Where's that? I want the y to the x, which in this problem is the inches over books. So inches over books. All right, again, let me go over this process. When you're reading your graph, you're starting at 0, 0. You're looking for friendly points. So I'm going to follow the line, follow the line, follow the line. To me, that's the first friendly point we come to. I don't even know if there's another one on this graph until you get way up here. So I'll just use this first one that I came to. And I'll get the y value, or the inches first. And the x value there is 4, 5/4. And then I'm going to write that as a decimal so I can express it as a unit rate. So I'm going to box this in because this is the slope of the line, 5/4. But I want to express this as a unit rate also. So if I take 5 and divide it by 4 on my calculator, I'm going to get 1.25. And that represents the inches per book. In other words, each book had a width of 1.25 inches. All right, problem C. Again, we're going to read our graph. We're going to look what's on the x-axis, what's on the y-axis. So on our x-axis, we have the number of lunches. On the y-axis, we have the total cost. So let's write down what we're comparing here. We're going to get the ratio of y to x, which in this problem is the cost. I'll just put dollars for cost to lunches. We're getting the ratio of the cost per lunch. Okay. Now, in this graph, we just have some discrete points here. So I want to find one that's friendly, because when I'm looking at them right now, the first one doesn't look really that friendly to me. It's very close, but not quite friendly. So I'm going to go up, look at each point until I find one I like. Wow, I didn't find one I liked till I got to the very end. So we're going to use this one right here. That's the most friendly point we have. So I want the y value, which is 18. Compare it to the x value, which is 8. And if I put that in my, well, I should probably reduce it. So let's divide those both by 2. That would be 9/4. Now, this is a correct answer. This is the slope. But when we're talking about money, we don't usually leave money problems in fraction form. So let's put that in your calculator and divide that. 9 divided by 4 gives us $2.25 per one lunch. Okay, $2.25 per lunch. All right, problem D. Now, don't let this one bother you because you see negatives. We're going to do it the same way. We'll look at the x-axis, time. We'll look at the y-axis, depth. So what we're comparing here, y, the ratio of y to x, we're going to get the ratio of the number of inches to the number of hours. The ratio of inches to hours. It's just that this time 0, 0 is way up here. All right, so please don't let it bother you that there's negatives. We're still going to follow this line looking for any friendly point we can find. To me, this is the first one that I find, so this is the one I'll use. All right, so my y value there is negative 10. My x value is 5. If we divide that, we get negative 2. So if I write that as a unit rate, it would be negative 2 inches per hour. Negative 2 inches per hour. Now, I'm going to show you in the next example how this might be tested on a unit test or a standardized test. In example 4, it says a printing store used 24 ounces of ink in 18 hours. So they're comparing the ounces to the hours. So I'm going to put 24 over 18. Which graph has a slope that best represents the number of ounces of ink used per hour? Now, let's look at the answer choices. If I look at the x-axis, we have time. And on the y-axis, we have the ounces, the amount of ink. And so I want to find 18 hours. But if you look at your graphs, each one of them only goes up to 10 hours. So we're not going to find 18 hours on there. But that's okay because we can reduce our fraction into smaller terms. So if I were to divide both those terms by 2, 24 divided by 2 is 12, and 18 divided by 2 is 9. Would that ratio be on there? So 9 hours is definitely on the graph. So pause the video and try to find a graph where they've used 12 ounces of ink in 9 hours. All right, let's see how you did. All right, I chose graph C because for 9 hours, they used 12 inches of ink. And that concludes today's lesson, Unit Rate as Slope.